Imagine a 20-story skyscraper falling from space, and then casually sticking the landing. Yeah, rockets can do that now. But how does a metal tube packed with fuel land more gracefully than most people parallel park? Let's break down the science.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.
For decades, rockets were single-use, like throwing away an airplane after every flight. NASA reports that launch costs dropped dramatically thanks to reusability. SpaceX boosters can fly 10 to 15 times or more. That's why reusable rockets are such a big deal. After delivering its upper stage, the booster flips around using cold gas thrusters. Then comes the Boostback burn, firing engines to cancel its sideways velocity and aim back home. NASA's guidance reports describe this as solving a giant mid-air bowling trick, hitting a moving target while falling at Mach speeds. As it falls back through the atmosphere, air slams into the rocket so fast it heats up thousands of degrees. A re-entry burn slows it down, and those metal waffle-looking things, grid fins, act like steering wheels for hypersonic descent. According to AIA research, grid fins give precise control even when the air is thin and chaotic. Here's the crazy part. Nobody's piloting this. Rockets land themselves, using GPS, IMUs, and radar altimeters. Tech straight from NASA's navigation research. The booster calculates its position dozens of times per second. It constantly adjusts its angle to stay upright, which is harder than balancing a broomstick on your finger, but at hypersonic speed. The rocket fires a final landing burn, basically a controlled reverse explosion. This reduces its velocity to near zero just seconds before touchdown. The landing legs deploy, absorbing shock and stabilizing the booster. The precision? Within meters. Way more accurate than your phone's GPS. Reusability is changing the economics of spaceflight. NASA's Launch Services Program notes a significant cost drop since reusable boosters entered regular service. That means cheaper satellites, faster missions, and, eventually, more access to space for everyone. We're still at the beginning. Next-gen rockets like SpaceX's Starship and Blue Origin's New Glenn aim for full reusability, both booster and upper stage. If engineers crack that, it could be the moment rockets become as reusable as airplanes. A skyscraper that lands itself. A booster surviving space, fire, wind, and physics, just to stand politely on a tiny ship in the ocean. Which part blows your mind the most? The autonomous guidance, the grid fins, or the landing burn? Tell me in the comments, and stay curious with SciCurious.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.